Let's look at the connection between f prime and the original function f. So we're looking at what happens, what the derivative is really telling us about the graph. So, if f prime is 0, then f of x has a horizontal tangent line. This means we have a possible relative max or relative min. If f prime is positive, that means we're going up. So that means the function f of x is increasing. If the derivative is negative, we're going downhill, so it is decreasing. If it changes from positive to negative, that means it was going uphill, and now it's going downhill. So at that point where it changes from positive to negative, we're changing from increasing to decreasing, so that means we have a relative maximum. And if we change from negative to positive, we have a relative minimum. So let's say we were given the graph of a function. What would be our possible graph of f prime? So let's kind of break this apart. I'm going to use some bright colors for this. So my graph is increasing from here, to here. And it's increasing from here to there. So that means on the derivative, on those sections, f prime is positive. Ooh, can't see that very well, so I'll write f prime is positive. When we're going downhill, we're negative. So at each of those turning points, my derivative is going to be at 0. So this is at -4. So over here, I know I'm going to be at 0 here. I'll be at 0 here. And then I'll be at 0 when x is 5. So this part, my graph is positive, negative, positive, negative. So positive means it's above the x-axis, so it's coming down. And then it's going to go down, and then it's going to turn around, and then it's going to turn around, and then go down from there. So let's see if that matches up. So from here to here, my derivative is positive because my function is increasing. So in this part, my derivative is positive. It's above the x-axis. Decreasing, so my derivative must be negative. And these are negative values. Increasing from here to here, so my derivative would be positive. Decreasing, so my derivative would be negative. we have a function. Looks very familiar. Answer the questions that follow about f prime. Approximate the value of f prime of 4. So approximate means we're going to find the slope of the secant line around it. So when you see those words approximate, think slope of secant line. So we're at 4, which is in here, right? So when x is 4, it's right here. Now to estimate, we're going to use the 2 points around it. So we've got this point, which is at 3, -1, and 5, 4. So to estimate f prime, to estimate, we find the slope of the secant line, or approximate. So it's an approximation symbol, and we just find the slope. y2 minus y1 over x2 minus x1. It's approximately 5/2. At what values of x is f prime equal to 0? So the way we would answer that is we would say f prime of x equals 0 when x equals, so there, there, and there. So when x equals -4, 1, and 5. And why? Well, because f of x has a horizontal tangent. On what intervals is f prime less than 0? Okay, so we'd start by answering our question. F prime of x is less than 0 on what intervals? So less than 0 means we're decreasing. So from -4 to 1, and then from 5 on, so 5 to infinity. Why? Well, because f of x is decreasing on those intervals. What about when f prime is positive? Well, that's as we approach to -4, then from 1 to 5. So I would say f prime is positive on -infinity to -4, and then from 1 to 5. Why? Well, because f of x is increasing on those intervals. At what value of x does the graph of f prime go from being below the x-axis to above the x-axis? So what it's asking there is if f prime goes from below to above, that means f prime changes from negative to positive. So f of x changes from decreasing to increasing. So where does that happen? Well, that happens when x is 1. At what value of x does the graph f prime go from being above to below? So what it's really asking is, when does f prime change above the x-axis? Would be from positive to negative, which means f of x changes from increasing to decreasing, which, if I look back at the graph, that's when x is -4, and then when x is 5. Oops. Picture below is the graph of f prime. Answer the following questions about f. Ooh, okay. So this is f prime. At what open interval is the graph of f of x increasing? So I would say f of x is increasing when f prime is positive. Sometimes it helps to actually write the reason first and then answer the question, which occurs on what intervals? So when is f prime positive? Well, this is the graph of f prime, and it is positive right here. It is above the x-axis. So the x values that give me that are from -3 to -2. On what interval is the graph of f of x decreasing? Well, f of x is decreasing when f prime is less than 0. So it is less than 0 from here to here, then here to here. -2 to 2, and 2 to 4. At what values of x does f of x have a horizontal tangent? So let's think back. F of x has a horizontal tangent when what is true? Well, when f prime of x equals 0. Remember, this is the graph of f prime, so that's occurs I should say which occurs at x equals -2 and x equals 2. Right there and right there. At what value of x does f of x have a relative maximum? So f of x has a relative maximum when f prime changes from positive to negative, which occurs at, so let's look back at the graph. There's only one place that f prime changes from being positive to negative, and that's at x equals -2. When does it have a relative minimum? So always start with your condition. F of x has a relative minimum when f prime changes from negative to positive. Let's look back at our graph. This was positive to negative. It never does. So which never occurs. What is the slope of the normal line to the graph of f of x at x equals 4? Well, let's think. We're given the graph of f prime. So f prime of 4 would be the y value from this graph. So that's negative 2. Which is the slope of the tangent line at x equals 4. The normal line is perpendicular to the tangent line. So what does that mean its slope is? Well, it's the negative reciprocal. So the slope of the normal line is 1/2. Negative reciprocal of negative 2.